Let us look at the third problem. The mean and standard deviation of 6 observations are 8 and 4 respectively. If each observation is multiplied by 3, find the new mean and new standard deviation of the resulting observations. Okay, so what is given is the mean and standard deviation of a data which has 6 observations, and the mean and standard deviation are 8 and 4. And now if the observations are multiplied by 3, that is each observation is multiplied by 3, we have to find the new mean and new standard deviation of the resulting observations. Okay, so let us solve this solution. Given is what? The number of observations, that is n is equal to 6, then the mean is equal to 8 and variance standard deviation is equal to 4. Okay, so now let the observations be x1, x2, x3, x4, x5, x6. Okay, so let this be 6 observations. Okay, be the 6 observations. Now if we multiply this observation by 3, what we will get? Since the 6 observations are multiplied by 3, so we get, or so the new observations are 3x1, 3x2, 3x3, 3x4, 3x5, 3x6. Okay, now let us find out the new mean first. So new mean will be nothing but the sum of the observations divided by the number of observations, So that is nothing but 3x1 plus 3x2 plus 3x3 plus 3x4 plus 3x5 plus 3x6 divided by 6. Okay, so now what we can do is take 3 common from all the 6 observations. So we will get 3 times x1 plus x2 plus x3 plus x4 plus x5 plus x6 divided by the number of observations, that is 6. So that is nothing but 3 into, now if you observe this is nothing but the mean of the original 6 observations. So this is nothing but the mean. So that means 3 times the mean is given as 8, right? So that means what we will get is 24. So the new mean is 24. Okay, now let us find out the new standard deviation. So new standard deviation is equal to root of a new variance, right? New variance. So that means this is equal to root of So variance, how we have to find out? So that is nothing but 3x1 minus the mean, new mean, that is 24, the whole square, right? This is the first term here, then plus 3x2 minus 24 the whole square, right? So similarly plus 3x3 minus 24 the whole square. So I am writing what 3x1, that is the new observation, right, minus the mean of the new observation, that is new mean, that is 24. So similarly we will get this, then plus 3x4 minus 24 square plus 3x5 minus 24 square plus 3x6 minus 24 square, and then this is divided by 6, right. So what we will get is equal to root of we can take 3 common from this. So what we will get is bracket 3 x1 minus 8 the whole square, then similarly what we will get is 3 x2 minus 8 the whole square then plus 3 x3 minus 8 the whole square plus 3 x4 minus 8 the whole square, then plus 3 x5 minus 8 the whole square, and okay, and plus 3 x6 minus 8 the whole square. Okay, let us just make the root a little big here, and this is divided by 6. So this is equal to root of, what we will get is 3 square is 9, then x1 minus 8 the whole square plus 9 x2 minus 8 the whole square plus 9 x3 minus 8 the whole square plus 9 x4 minus 8 the whole square plus 9 x5 minus 8 the whole square plus 9 x6 minus 8 the whole square. Okay, so this is the whole divided by 6. So this is equal to, now if we take 9 common from all the observations, from all the terms we take 9 common, and we will get 3 here when we take root. So we will then get 3 times root of x1 minus 8 the whole square plus x2 minus 8 the whole square plus x3 minus 8 the whole square plus x4 minus 8 the whole square plus x5 minus 8 the whole square plus x6 minus 8 the whole square, and then this is divided by 6, right. So this is nothing but 3 times this is nothing but the root of variance, right, the original variance, that means 3 times standard deviation. So what we will get is 3 into standard deviation of the original data is 4. So 3 times 4, which is nothing but 12. Okay. So the new variance is 12. So that is the solution of the third problem. Now let us go to the next one, the fourth one. So this fourth problem is just the generalization of the previous problem. Okay. So the solving is same. Okay. Yeah. So given that x bar is the mean and sigma square is the variance of n observations x1, x2 up to xn, prove that the mean and variance of the observations ax1, ax2, ax3, axn are ax bar and a square sigma square respectively. A is not equal to 0. Okay. Let us solve this solution. So what is given is the mean of the original observation is x bar. So mean is equal to x bar and standard deviation variance is given, and variance is equal to sigma square. This is given to us. Okay. So now let us find out the new mean. Okay. So the mean of this data ax1 comma ax2. So also we can write this here. Before this we can write, this implies x bar is equal to x1 plus x2 plus dot 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 xn divided by n. Okay, this we will call it as 1, and since variance is sigma square, so sigma square will be equal to x1 minus x bar the whole square plus x2 minus x bar the whole square plus x3, or we can write dot 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 here, plus xn minus x bar the whole square divided by small n. Okay, this we will call it as 2. So now let us find out mean of the new observation. So mean of ax1, ax2 up to axn is equal to, so mean is nothing but the sum of the observations divided by the number of values. So ax1 plus ax2 up to axn, and that is divided by n, right. So if we take a common, what we will get is x1 plus x2 up to xn divided by n. Okay, so this is nothing but a times, this is from 1 x bar, right. So this is from 1. So mean of ax1 up to axn is nothing but a x bar. So that answers the one part of the question. Okay, and now we will go to the new variance. So variance of ax1 comma ax2 up to axn is equal to what? So you will get ax1 minus the mean of the new observations is this ax bar. So ax bar here, the whole square, because variance we are finding, then ax2 minus ax bar the whole square. Okay, then up to axn minus ax bar the whole square divided by n. Okay, So this is equal to, now we can take a common from this, so a times x1 minus x bar the whole square plus again a common from this, a times x2 minus x bar the whole square and so on, plus a times xn minus x bar the whole square. So this is divided by n. So if we open the bracket, so square will go to this a, so a square into x1 minus x bar the whole square plus a square into x2 minus x bar the whole square and so on up to a square xn minus x bar the whole square divided by n. Okay, so this is equal to, now we can take a square common from all the terms, so a square and into x1 minus x bar the whole square plus x2 minus x bar the whole square plus and so on xn minus x bar the whole square, and then this is divided by n. Okay, so this is equal to a square, and if you observe this properly, what you have is the second equation here, right? So into what you will get is sigma square, so that is nothing but a square sigma square. So variance of the new observation is a square sigma square. Okay, so we have proved both the parts, so we have to write hence proved, hence proved. Okay, that is the solution. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.